In this video, we will discuss about the variations in Turing machine. Before studying about it, we should know what is Turing machine. Turing machine is described in 1936, well before the days of modern computer, but it remains a popular model of computation on today's system. A Turing machine consists of a finite control that is connected to an infinite tape with the help of a read-write head. The tape consists of cells where each cell holds a symbol from tape alphabet. The Turing machine is denoted by 8 tuples. That is, Q is the set of states, sigma is the set of input symbols, T is the set of tape symbols, del is the transition function, Q naught is the initial state, B is the blank symbol, QA is the set of final or accepting states, QR is the rejecting state. Here you can see the model of the Turing machine in which finite control is connected to an infinite tape with the help of read-write head. Now Turing machine variants. There are many variations can be possible in basic Turing machine. These extensions can make it useful to prove a theorem or to perform some task. For example, consider a variation in Turing machine where we have option to keep stationary head or to make it moving left or right. Types of variations in Turing machine. We will discuss the 4 types of variation in Turing machine, that is two-way infinite Turing machine, multi-tape Turing machine, multi-track Turing machine and non-deterministic Turing machine. Two-way infinite tape Turing machine. A two-way infinite tape Turing machine can move indefinitely in either both directions. A two-way infinite tape Turing machine is a machine with its input tape infinitely can go in both the direction, that is left or right. The tape head, as usual, can move in forward and backward direction. A two-way Turing machine is of 8 tuples, that is, Q is the set of states, sigma is a set of input alphabets, square is the blank tape symbol, Q naught is the initial state, T is the accepted state, and R is the rejected state. In this direction, you can see that the tape goes infinitely in left direction, and in the other side the tape goes infinitely in right direction. Now, multi-tape Turing machines. A multi-tape Turing machine is like an ordinary Turing machine, but it has several tapes instead of one tape. Initially, the input starts on the tape 1 and other tapes are blank. The transition function is changed to allow for reading, writing and moving the heads on all the tapes simultaneously. This means we could read on multiple tapes and move in different directions on each tape, as well as write a different symbol on each tape, all in one move. A multi-tape Turing machine can be formally described as 6 tuples, that is, Q is a finite set of states, X is the tape symbol, B is the blank symbol, del is the transition function, Q naught is the initial state, and F is the set of final states. By this diagram, we can easily understand the multi-tape Turing machine. It consists of a finite control which is connected to the multiple tapes with the help of multiple heads, while the single tape Turing machine consists of a single head connected to a single tape. Now, multi-track Turing machine. Multi-track Turing machine is a specific type of Turing machine that contain multiple tracks but just one tape head that reads and writes on all tracks simultaneously. Here, a single tape read and write the symbols from n tracks at one step. A multi-track Turing machine also consists of 6 tuples, which is similar as the multi-tape Turing machine, except the transition function, which consists of the multiple tracks from A1 to AN and B1 to BN. This diagram explains the Turing machine with multiple tracks with one tape head to read the K symbols from the K track at one step. Now, the last non-deterministic Turing machine. The non-deterministic Turing machine may have a set of rules that prescribes more than one action for a given situation. It involves an element of choice. That's why it has a non-deterministic flavor, just like as a non-deterministic finite automata. A non-deterministic finite machine may have moves available which lead to a non-final state or to an infinite loop. A non-deterministic Turing machine have 7 tuples, that is, Q is the finite set of states, sigma is the input alphabet, T is the tape alphabet, del is the transition function, Q naught is the initial state, B is the blank symbol, and F is the set of final states. A non-deterministic Turing machine is allowed to have more than one transition for a given tape symbol. This diagram explains the non-determinism flavor of Turing machine, where we have two choices. Either you can go from Q1 state to Q2, or you can go from Q1 state to Q3. So we have discussed all the basic variations in Turing machine. After studying these variations, we can understand that these variations helps us to prove many theorems and to perform many tasks. Thank you.